Hello guys, this is Professor AutoCAD here. Welcome back. In previous Quantum Story Club, we have talked about how Hertz proved the existence of electromagnetic waves by accident and discovered the photoelectric effect. And today, we will be talking about the second cloud in physics, the black body radiation. First of all, let's talk about what is a black body. So the term black body was suggested by Gustav Kirchhoff in 1862, but black body doesn't refer to something black in color. It means that when the electromagnetic wave hits an object, all the electromagnetic waves will be absorbed by the object, and there will be no transmission or reflection. This object is a black body. An object black in color, it can absorb visible light. We know that visible light is also part of the electromagnetic spectrum. So black objects can absorb visible light, but not necessarily all other electromagnetic waves. So a black object is not necessarily a black body. If you can understand this logic, then some of you might ask, can the black body absorb all electromagnetic waves? Yes, it can. So it's very likely black in color observed by the naked eye. And we know that this electromagnetic waves is a kind of energy. So won't the energy level of the black body become higher and higher? Won't it explode in the end? Well, the answer is no. Why? Although we say that black body can absorb all electromagnetic waves, but no one stipulates that it cannot radiate electromagnetic waves. Yes, a black body can radiate away electromagnetic waves through another form, such as thermal radiation, in order to achieve a state of thermal equilibrium with the surrounding. This is a black body. So black body has a property that is its radiation pattern is only related to the temperature of the surrounding and has nothing to do with other types of radiation. This has high research value. So people feel like, oh, it's really worth researching. Let's dig deep into it. But there is no such absolute black body in real life, at least not till now. We haven't seen anything that can absorb all electrons and electromagnetic waves. Or you can say that the sun can be approximated as a black body, but no one can really bring a sun down to Earth and do research. Then what should we do? What should we do to do the research on the black body? Well, there is one way. Metal can shield off electromagnetic waves. We all have experienced that we are in an elevator. Our phones would suddenly lose signal. An elevator can be regarded as a metal box. Or in other case, you cannot receive any signal in a room sometimes. It is because the steel structure in the wall is too dense, which causes the signal to be blocked away easily. So, what can we do? We can make a metal shell, this metal cavity, then open a small opening, and electromagnetic waves are continuously emitted into the cavity through this opening. Then the electromagnetic waves will bounce back and forth inside and cannot escape. So we can see that all electromagnetic waves are absorbed by this metal cavity, an approximate black body. Good, we now have a black body. We can start doing our research. So we would particularly focus onto the study of the energy density of the black body under different frequencies of electromagnetic waves. So based on this experiment, the data was measured, and such a curve was drawn. It doesn't matter if you don't understand this part, you can just know that this curve represents a property of the black body, and then this curve is drawn based on the experimental measurement results. We now have the curve. Please do the explanation. Just like how we mentioned the hydrogen spectrum series, Balmer gave us a formula, and someone must explain it. The scientists began to study why the energy curve of the black body looks like this. The first person to give a formula is called Wilhelm Wien, a German physicist who once worked in Helmholtz's laboratory. Wien gave this formula in 1896, based on a classical thermodynamic theory. We don't need to care about the specific meaning of this formula, but we can look at his curve, the curve of Wien's formula. It fits well at high frequencies, but at low frequencies, it's just a bit off. People at that time thought, it's not that bad, it's already quite a perfect line. The deviation might be a matter of a small experimental error. So in 1911, Wien won the Nobel Prize in Physics. There is also a crater on Mars called Wien. Funny that scientists really love naming craters after other scientists' names. Lunar craters for Balmer and Herter, now Martian crater for Wien. But after all, this formula has deviations. Scientific research is like this. Everyone will study issues that are valuable. You can see that even though the Wien's formula has deviations, but he has won the Nobel Prize. So if someone got the perfect formula that fits the curve, you will definitely win the Nobel Prize. And it draws the attention of one person, who is the famous Rayleigh. There is a laboratory called the Cavendish Laboratory at Cambridge University in the United Kingdom. Later on, you will know that a large number of outstanding physicists have emerged from this laboratory. The first director of the Cavendish Laboratory was Maxwell, and Rayleigh was the second director of the laboratory who succeeded Maxwell. God damn it, Rayleigh is such a familiar person. The Rayleigh criterion was mentioned in my quantum physics, astrophysics, and medical physics backs in high school. But if you haven't heard of this person, let me tell you a few things about him. For example, when we were kids, we have probably read something like this: "I wonder why," or other similar things. There is a question asking people why can people distinguish sounds? Because of the binaural effect. This binaural effect was published by Rayleigh. And there's another question: why is the sky blue in colour? Rayleigh was also the first to give an explanation, which is called the Rayleigh scattering. Moreover, Rayleigh was the first person to discover inert gas. He first discovered the inert gas argon with one of his colleagues, and then people discovered the whole group of inert gas. In short, Rayleigh is a really wonderful person. Then, Rayleigh saw Wien's formula, so he decided to study it. At first, everything went smooth, but then something went wrong. Rayleigh also calculated the formula, and his formula depicted such a curve. That is to say, his curve fits quite well at low frequencies. But for high frequencies, especially the frequencies tend to infinity, the energy radiated from the black body will also tend to infinity. This would be really scary, which is basically the laser weapons we often see in sci-fi. That's why later generations named it the ultraviolet catastrophe. Rayleigh won the Nobel Prize in Physics in 1904, but it was because of the discovery of inert gas argon. Similarly, to commemorate Rayleigh, a Martian crater and a lunar crater was named Rayleigh, and an asteroid is also named Rayleigh as 22740 Rayleigh. In 1905, a physicist called James Jean, he re-improvised the Rayleigh formula, and later generations named it as the Rayleigh-Jeans law. Okay, let's get back to the problem of black body radiation. Now that we have two formulae to describe this curve, one fits well at high frequencies and the other fits well at low frequencies, classical physics is now at visible confusion again. But at this moment, a weird-looking guy carefully opened the door of quantum mechanics: Max Planck. Despite his weird-looking appearance, he was actually quite handsome when he was young. When Planck was a kid, he was really talented in music. He could play piano, organ, cello, and compose many pieces. When Planck was in college, his professor told him, "Almost everything has already been researched in this science, and only a few insignificant gaps still need to be closed." Then Planck told his teacher that he said, "I have no desire to break new ground, just to understand and maybe deepen the foundations of physical science that already exist." Before 1900, Planck was not as famous as Maxwell and Rayleigh, but he was a dutiful professor who mainly studied thermodynamics. In fact, before Wien proposed the Wien formula, Planck has been studying black body radiation. But then Planck really gave such a formula in 1899, 1 year before 1900, which matches the experimental curve. You can see that Planck's formula is very similar to Wien's formula, right? He subtracted a 1 from the denominator of Wien's formula. So, strictly speaking, Planck guessed the formula. And after thinking about it for a while, Planck finally published it in October 1900. As we mentioned earlier, that Planck carefully opened the door of quantum mechanics. Think about it. In year 1900, Planck was 42 years old and a professor. People at that age and status would be afraid of other gossiping. Oh, you see, you're so old and you guessed the formula out. Still, Planck decided to publish this formula. But because he guessed the formula, it didn't attract much attention. So Planck himself felt very sorry. I have to explain. I must. I'm such a big professor after all, so I have to make an explanation. So, on 14th of December 1900, Planck finally gave a theoretical derivation, introduced the energy quantum hypothesis, and opened the door to quantum theory and quantum mechanics. As the founder of quantum mechanics, Planck won the Nobel Prize in Physics in 1918, and an asteroid was also named after him, the 1069 Planckia. But it's really a pity that Planck's life was quite pathetic. He experienced World War I and World War II, had to keep running away. Planck's eldest son died in World War I, and his second son was taken as a prisoner for murdering Hitler and finally sentenced to death. He had two other daughters, both of whom died in childbirth. So Planck and his first wife's 4 children are all dead. You can see that scientists aren't gods. They can't change their own destiny. But what did Planck say on the 14th of December 1900? What was his publication? What are the details inside? That would be something for next time. Great, that's all for today. If you like my channel, please access the like button, follow my Instagram account, subscribe and turn on the notification bell. And I'll see you beautiful face next time. Bye!